Assalamu alaikum. Hello everyone, I hope you're doing great. Today we're gonna be building a robocar using Bluetooth. This is the car that we're gonna build. I'm just gonna turn it on to demo and I'm gonna scan. This is the application also that we're gonna build. I'm just gonna scan Bluetooth and I use many of them as you see, and I believe this is the last Bluetooth I used. And once it's connected, I'm just gonna go forward and I'm gonna stop. You can make a right, stop, can make a left, stop. So let's see how actually we got this working. So let's see how we can drive 4 DC motors with an L293D motor shield model. What you will learn, how to connect the L293D motor shield model to 4 DC motors, how to control motors using Bluetooth model, write an Arduino code, and test the motors using serial monitor. So list of material you're gonna need: a laptop, a USB cable, an Arduino. I used Arduino Mega in this, or the Steam Nord kit. An L293D motor shield driver model, 4 DC motors, a bunch of jumper wires, breadboard, and a 3-position toggle switch. So this is the material we're gonna need to build this project. And of course, a 9-volt battery. So let's see how many output terminal we can use with this L293 model. So these pins here is for 2 servo motors. We can control 2 servo motors with these pins here. The M1, M2 motors, M3 and M4 are connected through these pins. And if you want basically to connect a stepper motor instead of a DC motor, then we will be using these pins to connect stepper motor. So we'll have stepper motor 1 and a stepper motor 2. And let's look at the connection diagram, how we can actually connect this 4 DC motors, motor 1, motor 2, 3, and 4, with this L293D shield. So we have, as we mentioned, you connect the order doesn't matter because we can always swap and see which one is to give direction. So really, red doesn't mean it's positive. It's more like for orientation of rotation of the motor. So just connect as follow. These wires into this pin. The middle one is grounded. We are not going to connect it. The same thing as motor 2, and then motor 3 and motor 4. So connect them this way. And you're going to use your breadboard to connect your HC05 Bluetooth model. You know, always the receive be connected to transmit. Receive of the Bluetooth model be connected to transmit of which is pin 1 of the Arduino. This is the shield. The same thing. The receive and transmit of Arduino are mapped into the shield. And the transmit of the Bluetooth will be connected with the receive. So and because of HC05 Bluetooth use logic 3.3 volt instead of 5 volt like Arduino, we have to kind of bring down or lower the voltage from 5 volt to 3.3 so we don't burn the Bluetooth. So that's why we have this voltage divider, and we'll talk about this voltage divider later on. Okay, so note that receive is the only one that we have to lower the 5 volts, but the transmit pin, it's connected directly to the shield or to Arduino. And then you're gonna connect of course ground to ground and VCC to our 5 volt here. So once everything is connected, then you can put a battery, 9-volt battery, that's gonna supply voltage basically to the motors. And then notice there is a jumper here We don't have to power the Arduino. So this jumper is gonna basically power the Arduino for us, okay? So we need, as I mentioned before, we need to attach a voltage divider basically to convert the 5 volts logic of Arduino to 3.3 volt logic of Bluetooth. They use 2 different levels of logic, okay? So for Arduino, 5 volts will represent 1, but for Bluetooth, it's 3.3 volt that will represent 1. So we want to make sure that we don't burn it, and we create this divider here, voltage divider, by using 1K and 2K resistor, just like this. Just connect this, and later on we can actually see how this voltage divider works. So if you take this 1K and 2K and just straighten up, it will be the Vin voltage coming from the transmits. So it will be here going to R1, and then from here we're gonna branch to receive. That's the V out, and then R2. So this is the circuit that we will be using for the voltage divider. So what is the voltage divider? It's basically a common circuit used to lower high voltage to a specific voltage that we like. Like in this case, we want to lower 5 volts into 3.3 volts, so we don't burn the Bluetooth and we stay within the logic level of this device. So this is the diagram of that voltage divider. The formula we used, normally it's this is the formula. Normally use Ohm's law, and we're gonna see this in later tutorials. So V out coming from here, that is going to the receive of Bluetooth, equal to V in, which is 5 volts, divided by multiplied by this ratio R2 divided by R1 plus R2. Okay. And R1 is the voltage that is directly connected to the Vin, and R2 is the one that actually gonna kind of decide how much voltage is gonna go to the Bluetooth. Okay, just a simple approximation. If R1 is very small, we would be like really V out equal to V in. Okay, if R1 and R2 are equal, so I can replace R1 by R2, so we will have R2 divided by 2R2. So it's really, we will have V out equal half voltage of V in. So we will have, instead of, so for example, 5 volts, we will have 2.5 volts out. So you can see that this is giving you an approximation regardless of what is the value of the resistor, okay? This gives you an approximation of voltage, how much voltage, and how you can use it. But we're not going to worry about this for now. You can always go to this link, and it will provide you with a calculator. You can just plug in let's say 5 volts. I need 3.3 volts here. I need just say 1 kilo ohm resistor. 1 kilo ohm and 2 kilo ohms resistors are common used values for Bluetooth, and calculator notes that it just gives you basically approximately 2 kilo ohms. So if I just do kilo ohms here, calculates again 1.9, which is almost 2 kilo ohms. Okay, so follow these steps to build your car. I want you first to glue those DC motors that you have. I want you to glue those DC motors to this board I provided you using either a double side tape or a hot glue. You can also put a hot glue or a double sided tape on the Arduino Mega and put the shield on top, and then follow that diagram that I showed before to make all your connections, okay? And just one note, for Bluetooth, either don't connect the transmit and receive, or unplug this Bluetooth until you basically load or upload Arduino code into your Arduino Mega. So let's look at the code. So I'm providing you the code for now. You can just copy and paste it from here. Okay, so it's one code, but I had to break it because it's a long code. So part one, you copy part one, then copy and paste part two and part three. Okay, but let's see how actually the code is working. So basically, the first thing you need to do, you go to Sketch and go to Include Library, Manage Library. We're gonna be using a library from Adafruit. Okay, so that's the you're gonna just go here, Adafruit Motor Shield library, and as soon as you type these words, note that I already have my Adafruit version 1. That's the one I used. Okay, it's already installed. It says installed. I'm not gonna update it. So you have to click on here and say install. So first thing you do, please include this library. So once you do that, okay, you're gonna type include in your code. You're gonna type include this library, okay, and so this library use a class called the Adafruit DC motor. You're gonna create 4 objects. I created the object 1 called motor 1. You can call it something else. Let's say forward 1, or whatever name you want to name. Just make sure it's attached. So I created the 4 objects. Basically, we have 4 motors. So this is object, let's say motor 1. Then another object called motor 2 and motor 3. And motor 4. We don't have to do anything with this library. Everything is done for us. In the setup, we're going to be using serial communication. So do the serial dot begin, and I use the baud rate of 115,200. That's the baud rate I used. Basically serial print ln, just basically to print something on the monitor, since we're doing it's a robotic club. You don't have to, this statement here you don't have, but this one you have to write it. And then I'm gonna set up initially the speed. So there is a function called set speed. So I'm taking object 1, which we created here from this class, okay, AF DC motor, and I'm gonna set the speed to 100%. The reason I'm using 100% because the with Arduino, it uses 8 bits, and we don't want to use from 0 to 255 levels. So the only thing I did, you will see this function here called speed percent, and we have to give it an integer, and we're gonna map basically using this mapping function. We're gonna map the value from 0 to 255 to 0 to 100%. I mean, like a full speed 100%. 0 is standing still, okay, and it's going to return that value. So this is the function we're using here, okay. Motor 2 is the same thing, motor 3, motor 4, and then I use this another function in a parameter called release with the ran function. So basically release is really cutting the power. So we don't use the brake, but there is no power, so the motors are off, okay. So this is in our initial setup, okay. In void loop, so basically we're gonna check, remember that application I showed you before? Let me just show it to you again. You remember when we, for example, when we click on F, we are really sending character or string F, okay, an ASCII code for that, okay. So when clicking on backwards, or we send in a character from our mobile application, character B to Arduino through Bluetooth. So right, we're sending the character R, and left, we're sending the character L. So basically, that's what we're doing here. We in the lookup, we're just checking if we're getting any information coming through Bluetooth. So we're gonna look at that serial connection. If there is any value that we read coming on the serial link, we're gonna basically we created a character name. We named a character called value, and we did the read on the coming in signal. So if a value, for example, this is just to print on the serial monitor. Really, you don't have to put it there if you don't want to. So if the value is equal to F, it means forward, then the code we're gonna basically just print again. This is just to print on the serial monitor, but this is the main code, is right here, okay? So basically we're gonna run this function on the object, all the motors on object 1, 2, 3, 4, run function, and we're gonna set the parameter forward, so it's gonna move forward, okay? And then if we receive B means backward, then we're gonna run the same function, but then the parameter is gonna be backward. So we're gonna reverse basically a rotation on the wheels, okay? The same thing for if we receive R for right. You know, this is kind of not the best way, but it does a job. You know, we can always optimize it. So the front, what I did here, the front two wheels gonna be moving forward like this, okay? Speed is gonna be 50% on the back wheels. So I only, this wheel, basically that is gonna be rotating backward, while these two here are going forward. So it's gonna make this rotation like that, okay? We can always play with the percentage here and make it better and optimize it. The same thing for left. So moving always the front wheels forward, and one of the wheels, so it's gonna be the other side, make it backwards, so it turns either left or right. So that's what basically, and then for stop, if we send this an S character, so we're gonna cut off the power from all the motors. So we're gonna use the run function, and that's how basically this program works. And for the Bluetooth model, we will use it in another class, so we spend more time on that. Okay, we'll use MIT Inventor app for that. Okay, well, thank you, and enjoying your RoboCar. Turn on. Choose the application. Scan. Forward. Backward. Forward. Stop. Backward. Stop. Right.